I know that I am not very environmentally friendly if we really look at things overall because I print tons of paper. But that's part of my job. So anytime we can save paper, I try to do so. So you want to get to the 7.2.2 lesson page. And then when you're looking at the 722 lesson page, the thing we're going to end up talking about together, nice, is this 722 resource page. Sorry, no, wait. It's right here, 743 student e-tool. So in number 43, not Desmos. We're not, well, it's in Desmos, but we're not doing a Desmos activity. So it will look like this. Black screen. Whoosh! I didn't want you to spoil the end of the movie. Well, that's even. What just? Oh, you just accidentally. Sorry, yeah. If you don't watch your footing, I've kicked that a million times. Maybe I should just build a different table thing to go there.
Wait, what? I can't. I don't know how to get there. What?
Okay. Let's reset because we haven't done this in a while. If you Google CPM ebooks, then it normally. Well, it's not going to do it right now. It sometimes will pop up with like the options. You can't go to homework help. If you're used to going to homework help, you can't because you need the lesson right now. So Google CPM ebooks, take the web, or just type in ebooks.cpm.org. My bad, I said .com a little bit ago. .org. You'll log in with Google. You'll go to the Math 8 textbook, which is the only one you have. It's in English or it's in Spanish. You'll go to chapter 7, and you'll go to 722. Because we're dancing.
Which problem?
Because I'm dancing. 43. So, we could.
That's not in 722.
I believe it is.
It does. What?
I believe it is.
I went to homework help. Yeah, that's what I did. I feel so
Man, if only somebody had warned you that you can't go to homework help. If only somebody had said that out loud to give us the warning that homework help website won't get us where we want to be. Man.
We're really supposed to finish this. Max, the rest of your stuff is over here. He knows. I know. Is this 7?
I think he realized his Chromebook needed charged, and that's why he moved. I know, but 722. All right, let's reset. Hey, friends, we're going to go over homework in a second. I just wanted you to get where you're going in the Chromebook. So if you are looking at the screen that you should be looking at, where it says Biking the Triathlon, go ahead and halfway close your Chromebook. Do not close it all the way. Get out 713. We checked that yesterday. It is due today. Some of you turned it in already, but if you turned it in, you should have already gotten it back, unless you turned it in the last 5 minutes. Because I graded papers like 20 minutes ago. 721, we're going to talk about together and take questions. So let's look at 721 together.
Oh, wait. I have not completed 721. We're looking for 713.
Sure. But yesterday we looked at 713 and we talked about how this line of best fit is approximate. Hey guys, I know some of you are talking with good purpose, but other of you are just talking.
Just to talk.
So 7-3, your answers are all going to be like approximate because it's all based on the line that you drew. But your line needs to be close to this line. Doesn't have to be perfect. But if your line is like way far away from points, it's not a very good line.
Obviously.
It is not the line of best fit if it's not the best one you can draw.
Wait, did I just turn in 713? Yes, I did.
Hey, Jake, not the Jake show, right? I know, it's not the Jake show. So then, 31, what goofed some of us up with the whole like answers will vary. I kind of disagree with that. Let me grab my copy of this homework to put in front of the doc cam. So when you add in the staff members' donations, that is not the only thing you have now. We're adding that to the data, unless I'm remembering the wrong problem. Yeah, I'm remembering the wrong problem. I'm remembering 39. Yeah, I'm talking about 39, not 31 right now. So 31 is still the Team 2 data, the depth of the seed, all that. Sorry, 30. 31 is the museum question. So the median, remember we have to put values in order from lowest to highest. Interquartile range, you first have to find your quartiles. If you got the wrong interquartile range, go back and check your quartiles. Your upper quartile should be 870. Your lower quartile should be 593. That is the median of the lower half and the upper half, right? So the original median cuts our data in half. We have a lower half and an upper half. We find the medians of those. Those are our quartiles. Questions, or does anyone need to see that one done? Brenda?
I have a question about another one.
Okay. About 31, though, does anyone need to see the quartiles found or the IQR? Max?
There's a man in the room.
I know there's a man in the room. Mr. Hall, that's Max. He has an interesting sense of humor.
I heard interquartile range. I thought box and whisker.
Yeah, that's what we had. Well, that's what we're working towards making. We didn't have one. We just had a random table of data. But we could turn this into a box and whisker.
If we wanted to, but we don't want to.
Well, I don't know. I might want to.
I don't.
All right, Brenda, question on a different question.
32A.
32A. Easiest way to tackle that one, in my opinion, is turn the decimal into a fraction. So you have 2/3 times 0.8. That's easier to think about if I think of that as 8/10. So that would then turn into 2/3 times 8/10, and we multiply straight through. We get 16/30. Both of those can be reduced. So 8/15 at least to start. And I think that's about as reduced as we can get. So, or we could get a decimal answer, but you guys know that my opinion is that fractions are better.
Would the decimal be 5 or 0.53 repeating?
Yes.
Okay, because that's what I have.
It's really sad how my brain figured that out, but yes. 1/15 is 0.03 repeating. I don't know why I know that, but I'm fairly certain that that is a fact. A true fact.
Wait, why did he?
No, it's 0.6 repeating, so what you should... No, you're right, because 7.5 15ths and then another half of... Yeah.
What?
Don't try to follow my brain. Amelia.
For that same question, but can you help with D?
D. I don't know if I can. It might be tougher. This is 713. You can double check which homework it is by checking what number we're looking at.
I'm looking at these. Oh, wait, no, it's 4 too.
So, Max, we talked about this at AO, about if you're not totally in tune with what's going on, you miss bits and pieces and it turns into a thing. Just, you're good. Just, we're still in 713. Just wait for 721. Easiest or least difficult way to deal with this, improper. Because you know I love fractions better than decimals, but also I like fractions, just fractions, better than mixed numbers. So this is really -4/5 times, make this improper, and it's 4/3, but make sure we take that negative with us. As I've told you guys and tried to brainwash you, the negative should live in the numerator. It's not right versus wrong, it's just easier for your brain. Negative times negative is positive, 16/9. Or 1 7/9.
Can you do 933A? How'd you get the 9? It's 15.
Oh, sorry. I looked at that as a 3. Hey, if y'all are going to judge me, you better never misread one of the numbers that you wrote. Yeah, 3 times 5. 5 times 3. This is 15. making this 1 and 1/15.
Or
Look, some of you have literally gotten questions wrong because you wrote down a 4 or a 9, and then you went back to it and thought it was the other number.
I have a serious question.
So no judgment towards me.
Where did the 9 come from?
I might have messed up on that one.
I thought this was a 3 when I looked at it really quickly. So 3 times 3 would have been 9, but it's actually 5 times 3.
so you're basically right no matter what.
Well, not. No, mathematically, I'm only right if I get to the right answer.
But
But...
like you were right in the sense that you read it wrong.
All right, anything else from 1-3? Amelia.
B of 733.
B of 733. Is it just that you don't have the same answer as them, or you got stuck in your solution process?
No, it's just that I didn't know how to solve that. I was confused.
So both of these do have denominators of 3. Get off my back. So negative 5/3, negative 1/3. I really have negative 6/3 x's. Are you still with me on combining the x's?
Yeah.
Then I have positive 1, positive 2/5. So I really have positive 7/5 because I'm going to think of this as 5/5. But since it's equal to 0, that isn't very helpful for us. We got to separate things or sort things. So the better way in my brain is if I push the x to the other side, right, utilize algebra to do that, it's going to become positive. So I'm going to add, really this is 2x, negative 2x right now. So I'm going to add 2x to both sides, making this turn into 2x equals 7/5. Because 1 and 2/5. 1 and 2/5 is 7/5. I just like impropers better than mixed numbers. Yes. I literally said that a couple minutes ago. I said just to wait for us to get to 721. So then we divide by 2. But another thing that division by 2 does is double your denominator. So division by 2 is the same thing as doing 1/2. Right? So division by 2, same thing as doing 1/2. So we get 7/10.
Yeah.
Good. Good.
Oh my god.
Good.
I have like 20 more steps than that.
Well,
I got 15 to get rid of the fractions. I got
I use fraction busters and
now you can.
I got the same answer.
You
but
just
it's
don't
like
have to.
20 more steps.
I just feel like
Well.
I took a longer time.
No. You just went you went the scenic route. All right. Anything else from 713? Brenda? 721
When's that due?
tomorrow.
Tomorrow?
But since you already probably worked on it last night, I'll take any questions you got. Max.
742.
We'll get there in a minute. You're way on the back page. I want to take. You haven't even looked at the answer for that yet, Maddie.
I am confused on how to do 738.
So let's. And I love how 5 different people have done this today. Let's reestablish something. I know that we're in chapter 7. You guys don't have to say 7. You can just say 38 or 39. And let's not say 38 or 39. Let's go ahead and be like mathematicians and say the number as it's spoken. So, you said 38, right? Oki is a western lowland gorilla. And guys, when CPM writes problems like these, they're normally from something that was in the news. So I'm betting that a decade ago-ish, I mean, I forget when CPM wrote their book. It hasn't been that long. So Oki loves to finger paint, and then they sell their paintings because who wouldn't want a painting made by a gorilla, right? Of course. So here's what confused you. And I left the phrasing how they wrote it because you will see things like this on a standardized test, and I want you to be ready for that. One painting sold for 5 times the amount of the second. So if I kind of draw a little picture here, that there are paintings, and no, I'm not going to actually make paintings.
Usually
So we say one painting sold for 5 times the amount of the second. If I don't know what the second cost, I don't know, P for painting. The third one was sold for $1,500. Okay, I know what this one sold for.
And then the first one sold for 5p.
The first one is 5 times the second one, so it's 5p. It's just the phrasing that messed you up. So now that we have 5p plus p plus 1,500 equal to 13,500. Right? Because they tell us the sum of all of the paintings selling. So then, how many P together? That sounded weird. 6P. And if I go ahead and subtract 1,500 from both sides, because guys, I think we're far enough into our algebra study that we're getting comfortable. This is going to be 12,000. So then 2,000 for the cheapest, no, well, I guess the cheapest one was 1,500, but 2,000 for that next cheapest, and then 10,000 for that most expensive painting.
That's a lot of paint. Oh, it's just two.
Yeah, but it was made by a gorilla.
Also, when you said because the colors are so interesting, I'm like, yep, there's some kind of excrement on those paintings.
Some kind of excrement.
I can't tell what it is.
The subtle shades of brown just really come through. So, if we, see, guys, I told you, if you take a job, like if you become a middle school teacher, you never really have to grow up. You can make poop jokes for your whole life. So, here, what a couple people have come to ask me about is these values get added into this set. So these are not our only 3 values for part B. It's the entire set of these values, which you should have already put in order, or when you go to do part B, you should put in order. And then we also put the 55, 67, and 74 into that list. Remember, hey, look up here, because I don't want to do this whole problem. Remember, when you have a set of data, the median splits up the upper and lower halves, but then your lower quartile, or quartile 1, I just want to review some of the terminology here. That's the median of the bottom half, and if there is no middle number, like let's say you have 4 or like 6, I forget how many numbers happen here, you have to find the middle of those numbers. So Jake, help me out, because I know we worked on this earlier. What are the 2 numbers in between, or the 2 middle numbers here?
55 and 62.
55 and 62.
I memorized it.
So then we have to figure out what number is in between those. If it's not a nice one to do in your head, and sometimes the numbers are even worse than this, we add them. I know you can't see my screen. We add them together and divide by 2. That lets us find the middle of those numbers, which would then be our quartile 1. The median is known as quartile 2, which is why your upper quartile is quartile 3, right? Your median is quartile 2. So check your median, upper quartile, lower quartile. Oh yeah, look, 58.5. Go back and redo it if you need to. Totally fine.
I think I accidentally counted the median too.
Yeah, once you identify the median, it essentially gets taken out of your data. So if your median is a number that you have, it then is like removed, right? It doesn't count as part of the lower or part of the upper. It's gone. Like, it's still part of our data, but I can't look at it for the upper or lower because it's the middle. All right, we had a question for 42. Does anyone have a question on 40 or 41?
If anyone noticed, you could solve 41 by using the Toby-Benegini method.
Yeah.
Which was lots of fun.
Ooh, speaking of, that's the calendar thing that I talked about that has 12 just blank pages of that. If we decide 12 mathematical properties that we should like make posters for, We could let people do that at extensions or whenever they want, that we could make some new mathy posters. All right, so 42. What from 42 was somebody wanting to see? Was that Max or who asked for this?
That was me. I just wanted to see the answers. So I did.
Oh, well,
That was just, I wanted to make sure I got it right because
You're
I
good.
did a way that was, I did it for
I
my
just thought
Answer for 37.
I thought you asked for help. It was up here, but dude, we did. This would be an example of negative association.
I didn't know if the strategy I used was the way you wanted me to do it, but I think it's a bit different, but multiple ways to afford it, and I decided to go by crocodile.
So, did going by crocodile get you to the right place?
Yes.
So check your answers here for 42. Guys, it's mainly reviewing that because multiplying fractions is easier. So they keep throwing some addition and subtraction problems at you. Guys, this is real life. Like, not the, well, actually, it's probably not even a viral video anymore, but not like, oh, is this real life? Like, guys, look. I'm building something for my friend. It's like a replacement cabinet thing. And to build the box, sorry if this ever focuses, it might not because it's a digital camera pointed at a digital screen. To build the box, I have to compensate for the amount of overlap of the boards and subtract that from one of the sets of boards. So I have to account for the top and the bottom, so I need two of the boards. But two of the boards, their width is 1 3/8 inches. So I, in the real world, doing a project that will make me money, need to do a subtraction by 1 3/8. It's like not just what a teacher wants you to do. You know what I mean? Like, I hate when we say the real world, because everything's the real world. This is the real world, but this is not your real job. Right? Like, right now, you just come here because you have to. But what I mean is, like, when you are choosing, I'm going to take this job, I'm going to do this project, I'm going to build this thing, like, the stuff you actually care about, fractions don't go away. And you can thank America for that, because if we were in any other country, essentially, we would use the metric system, and we wouldn't have to use so many fractions. But alas,
Okay, well,
America!
America!
Dude.
So if since you put your thumb out there, you had 3 thumbs.
3 thumbs?
Yeah, because 2 of your thumbs are in the picture, and plus the thumb under the camera shows zooming in and out.
So there you go. Here's the project. I don't know if you'll ever be able to see that. I could just show you the drawings. But it's a replacement cabinet for a medicine cabinet. So,
I just cut it what I think it looks like.
yeah, just don't worry about the dimensions. Just do whatever just do whatever it looks like. All right.
Measure nuns cut twice.
Measure nunts? Yes, that's a word.
Yeah, we all know this is not a full word. We all know it.
I didn't see the last one for 742 last.
For 742. Negative 1 and 7/8. Negative 1 and 7/8.
Wait, how is
Sorry, 18ths. 18ths, not 8ths.
E5356? Couldn't you reduce it?
No, I don't think either of those have common factors, because 3 is not a common factor for 53 or 56, even though it looks like it might be.
I know, but like in like the problem, couldn't you just do 15?
No, because 7 and 8, their first common multiple.
Oh no,
You fell in the trapdoor of adding them together.
I looked at D.
Yeah, E has to have a common denominator of 56.
No. When I look at E now, it makes so much more sense. No, E and D sound so. Oh.
Wouldn't it be 12? Wouldn't it be 12 over 56? Because,
This?
yeah, E. Because 4 times 3 is 12.
Dude, we first have to go to common denominator. So for 7 and 8, our common denominator, the first one is 56. So times 8 times 8 becomes 32 over 56. Minus times 3 times 3, times 7 times 7. So 21 over 56, but minus a negative.
Cancel each other out.
Plus a positive. Don't say cancel each other out. They turn into plus. Turn into addition. All right, we got to be moving on. So, like the old story of the tortoise and the hare, we have a bike race. once I have a moment to give the setup. You gonna be all right?
Yeah, I'm good.
We sure?
Yeah.
Take a second and turn in homework if you need to, like Anna just did.
Wait, do we turn in 721?
You can.
I'll turn the 6. When is your turn?
At this point, I'm grading everything I can as quick as I can, and I've got new grade sheets and everything else. Whatever you turn in, I'll grade.
Cool.
So, in a anyone in here ever done a triathlon?
Many.
I wanted to.
Okay, well, Gust wants to flex and say many. Gust, what is in a triathlon?
Well, first you swim,
Okay,
then you bike,
okay.
and then you run.
Yeah, I will do the first two parts of it. Somebody else run for me. So you swim, then you bike, then you run. So we're looking at this triathlon.
I've done a triathlon once.
So we're looking at this triathlon here with these 4 different competitors, A, B, C, and D. One thing we notice right off the bat, well, we should check for labels of axes. So I don't see labels over there. Let's read and see if we can find some labels. Swimming portion, bicyclists have varying graph of the right shows. Ooh, 20-minute portion. Do we see another? Ooh, here's another label. Ah, kilometers per minute. So we can go ahead and glean. Glean is a fun word. It's like gather or like get from the information that you see. We can glean from this that this axis is going to be kilometers and this axis is going to be minutes, because when we use a graph like this to make a per statement, we're almost always talking y per x. Because that's what we do for slope, guys. Right? We talked about this like way back before winter break. So I want you to analyze the data that we have here. You can zoom in on your graph. You can click on your graph. You can do all kinds of different things in Desmos. But figure out who is riding the fastest. Not like who's winning, but who is riding the fastest. And you need data to support what you say. I don't want the answer yet, though. I'm sorry. I don't know what you want from me.
I'm at 1.4 times 10.
So work with your team. Make sure you guys agree. Work with your team. Whoa, okay, to throw evil in there, that's a little... So, this is the resource page that I saved some trees to not give you. Anna, do you want to talk to me about one of these cyclists? I don't care which one you want to talk about.
Can I just answer, like, who's going to be fastest?
No.
Well, that's that.
So then, the green person is going...
What? The green? I don't have colors on here.
Okay, well,
B. Okay, so B.
is going, like, it's 1 kilometer per minute.
So before I start comparing these triangles, what's one thing that I should double check about the graph?
Is it accurate?
Is it for...
Nevin, thank you for raising your hand. Scale. To double check, is this 3 actually 3? So I check my scales and I see they're both 1 to 1. Sweet. Good. So cyclist B, Anna says that triangle was 3/3, or really they're going 1 kilometer every 1 minute.
That's pretty fast.
It's fairly fast. They are on a bike, but that is fairly fast, right? Because that'd be 60 kilometers per hour, right? If we convert this up to an hour speed, that'd be 60 per hour. And oh, you guys gotta tell me if I feel like, if it seems like I think you can see what I'm showing and I'm like, and you can't. Yeah, that would earn you a piece of candy. Not the whole telling me to record, because I always record. But if I forget that my screen is locked, that can earn you a piece of candy. Max, right?
I am mad.
You want to give me information about another one of the cyclists?
B.
B's done. Try again.
A.
Because otherwise I'm coming back there and checking your internet history.
I'm actually on the thing.
Are you? Okay, tell me about A.
While it does seem like it's going the fastest, it's really not.
Why?
Because its slope isn't high enough.
What is its slope?
It starts the zooming mechanism is crap in this.
You could also just look up at the screen.
Step, so it's, would that be 6x or 4x?
You tell me.
4.
How do we talk about slope? Do we do the y over the x or the x over the y?
X over the y.
Other way around.
Dang it!
We do rise over run. So Anna got the nice one where it doesn't matter which order we do these in, because 3 and 3, they're both 3. But Max is doing a good job of reminding us. We take the y value first. So we'd say 4 kilometers per 6 minutes. Or we could reduce that to 2 kilometers every 3 minutes.
And then it's plus 5. Or is it 7? Is it 7?
What?
What? Because it starts, it's...
Oh!
Plus 7.
Yeah. We don't really care about that if we're just talking about speed, though. You're right. I'm with you now. I'm with you
I
now.
thought you were doing the algebraic equation.
No, we're just comparing speeds. So which is higher right now, 1 or 2/3?
Thank you.
1.
1 is better than 2/3 right now. Grant, you want to give me another? C or D? Give me some data. Did you guys talk about this together?
Did they?
Thank you, Max. I got it. Colin, you want to give me some information about C or D? So when I gave you time and said, figure out the speed of these, what did you guys do on your computers? Something else?
I was zooming out.
Like forever?
Me too. I am doing that right
I'm
now.
on the
It's
back.
really satisfying.
I did that first, but then I started doing the
I
math.
don't know to be able to zoom back in.
So
In D.
right now, and guys, this is January of your 7th grade year, this is a waste of time. What's happening right now is a giant waste of time. Everybody had time to work on this. Some people made a poor choice and did not do what you were asked to do. And now it's uncomfortable. So now my concern is, can I trust us to do the things I ask you to do, or do I have to walk around and babysit individual people? It's a dangerous thing. Jordan, are you going to be able to turn this around for us? Do you have information about C or D? Yeah, rider C or rider D. So you guys have it colored on your screen, but I pulled this out so we can try to. So C is actually this line, and D is over here. So this actually goes to rider C, and this actually goes to rider D, that triangle. You want to help me out with one of them? Careful. Y over the X. This is why we're doing this practice. So C is actually 2 kilometers per 3 minutes. Guys, it makes a lot more sense to say how far somebody can go in a certain amount of time versus saying, oh, they're riding at 3 minutes per 2 kilometers. Like, what? Like, we could flip this over and we could say 3 minutes per 2 kilometers, but that doesn't really, like, sure, you can say 1.5 minutes per kilometer. You can say that, and it kind of makes sense, and it's true, but it's not as useful, and it's not their speed. If you say how long it takes them to go a distance, that is not speed. You're right, Jordan, thank you. 2 over 3, well, that's just the same as A. Right? When we reduced A, we got to reduce 2/3. Maddie? D is the only one we have left. Sorry, is that what you just asked for?
Yeah.
Sure, what's D?
Okay. D is 2 over 4.
2 over 4. Which reduces down to?
1. Sorry, my calculator fell in between the cracks.
So 1 kilometer over 2 minutes, or you could say half a kilometer per minute. Questions on the triathlon problem? So a reminder that we should make to ourselves, either like in our notes or in our head or both places, is that slope is delta y over delta x. So slope, as we're going to start talking about it again, we talked about it before break, slope is y over x. We're running out of time is why I'm having a debate, a discrepancy.
Pardon the interruption. Can Allie Ridgway please come to the office for dismissal? Allie Ridgway. Thank you.
So, when we build our graphs, guys, you kind of got off easier today because I'm not asking you to write a lot. You can switch around your axes. And I think I'm still figuring out the best way to like get kids to understand this. Hey Max, I don't think we're on our computer right now. Most people are paying attention to me and it's obvious you aren't. I don't care, Clarence. I need your attention. I love your name, and I'm gonna pull it out when you're starting to get a little bit in trouble.
I don't know if you know, but you saying that just made my blood went cold.
Clarence Maximilian. Dude, when I would get in trouble, it was normally, I don't know why, it was normally at church, and I would just hear my mom yell, Micah Joseph! You know it's time to listen to mom. So,
Mr. Hudson, when my parents are mad, they call me Maximilian. When my parents are really mad, they call me Clarence.
so here's how we set up every graph we get to build. We ask ourselves, what depends on what? So here, the only way that our tiles are going to increase is if our figure number goes up. So what we would say is the tiles depend on the figure, and how we apply that with our linear situations is that y is dependent on x. Y is always, if anything is dependent on anything, y depends on x.
What would happen if y is not dependent on x?
Then it's just they're independent of each other. So
Ah,
they don't have to be dependent, but if there's a relationship between them, like how far I can go with how long I've ridden my bike, that's dependent. I can't just magically all of a sudden be at 20 miles, right? Like, because we live on Earth and I have to go like a foot at a time or whatever you want to say, right? I can't just magically jump there.
Also, very good
You're
judgment.
not invented to tell
So,
us yet.
we will pick this up tomorrow. 722 is your homework. We did not get to the other lesson.
So if y is dependent on x, then basically like x is y getting forced.
Mr. Hudson,
Not funny to joke about things like that, but so I don't want to overcomplicate things quite yet.
Okay.
The reason that our models look how they do and look kind of pretty, like straight lines, is because they're dependent on each other.
Okay.
not proportional relationships, right? Because that has to hit the 0, 0. So here we don't hit the 0, 0, but the amount of tiles we have is dependent on the figure. It's kind of like if I'm building with Legos or things like that. Like,
That's something I love to do.
yeah, like things are dependent on each. Like how much I pay for pizza is dependent on how many pizzas I order. Right? Like most situations in the world where I relate to things, one is dependent on the other.
Someday I'm going to invent a teleport and I'll be able to magically teleport to that pizza place.
Well, Star Trek will thank you.